Welcome to AI Podcast. I'm Ethan, and with me is Maya. Today we're turning our article into a conversation about a paper called Reflexion. It explores a simple way for language model agents to learn from their own mistakes without retraining.
Hey Ethan, Reflexion. Sounds like the agent literally reflects on what it just did, right?
That's exactly it. Quick takeaway up front. The agent tries a task, then writes a short note to itself about what went wrong and what to change next time. It stores that note as a memory and reads it before the next attempt. Those bite-sized lessons, written in plain language, improve performance across planning tasks, multi-hop question answering, and programming. No extra training, just better use of feedback.
So the agent isn't changing its neural weights. It's just carrying forward a lesson in words.
Right. Think of it as a semantic nudge rather than a gradient update.
Got it. Who led the work?
It was led by Shinn, with collaborators from Northeastern, MIT, and Princeton, including Karthik, Narasimhan, and Shunyu.
Okay, set the scene for me. What problem are they trying to solve?
Many agents built on large language models can plan, use tools, and reason step by step. But when they fail, they often just try again from scratch. Traditional reinforcement learning could help them learn from experience, but it's costly and slow to train at scale. The gap is practical. We want agents that improve over episodes like a human would, without expensive retraining. Reflexion treats natural language itself as the medium for learning. After each attempt, the agent condenses feedback into a sentence or two it can reuse.
We've seen chain of thought prompting and those think then act patterns. Why didn't those already solve this?
Great question. Chain of thought helps within a single attempt. React-style agents interleave reasoning and actions, also within one attempt, but most approaches don't keep a persistent, structured memory of what was learned across attempts. Other self-revision methods tidy up one answer, not a series of tries. Reflexion focuses on cross-attempt memory, keeping the distilled, reusable insight so the next try starts smarter.
Nice. How do they make it work in practice?
There are 3 roles. First, an actor model produces actions or an answer. Second, an evaluator checks how well it did. That evaluator might be an exact match check for a question, a set of tests for code, or a simple heuristic that spots looping in a text environment. Third, a reflection step turns the attempt and result into a short first-person lesson, something like, I misread the question, compute X before Y, or stop wandering, go directly to the pantry. The note goes into a small memory, and the agent reads those notes before the next attempt.
So it's like writing sticky notes to your future self.
Exactly, and the memory is intentionally small to keep the context clean, usually just a couple of notes.
What did they test this on?
3 settings. First, ALF World, a text-based household environment where the agent completes tasks by reading and typing commands. Second, Hotpot QA for multi-hop reasoning. Third, programming tasks, benchmarks like Human Evil and MBPP, plus a set of challenging problems they call LeetCode Hard Gym.
And the evaluation? How does the agent know whether to celebrate or to fix things?
In ALF World, the evaluator can detect unproductive behavior like looping or wandering. In Hotpot QA, it checks whether the final answer matches the ground truth. In coding, the agent actually writes its own unit tests, filters out invalid ones, and runs the code against them to judge success. That trustworthy signal is what powers better reflections.
Writing its own tests is clever, but also risky if the tests miss something.
Exactly. The authors point out that test quality is crucial. When tests are reliable, the loop gives good signals and the agent improves. If tests are flaky, the agent can reinforce the wrong lesson.
Why do verbal reflections help beyond, say, turning up the sampling temperature or adding a longer chain of thought?
Because reflections add targeted guidance, temperature adds randomness, longer chains add detail. A reflection is a distilled hypothesis about what went wrong and what to change. It's the kind of short coaching note a mentor would give. Here, the agent becomes its own mentor.
All right, results. What did they see?
Across the board, performance improves with just a handful of attempts. In ALF world, adding reflections on top of a strong agent helps it solve nearly all tasks and reduces failure modes like inefficient wandering. In multi-hop QA, the success rate climbs steadily as the agent accumulates a small set of lessons. In coding, reflection meaningfully boosts first-try success on well-tested benchmarks and shows gains even on very tough problems. The effect is strongest when the feedback signal is trustworthy and the base model is reasonably capable.
When you say first try success, you mean the metric sometimes called pass at one, right?
Right. If the agent only gets one final answer, how often is that first try correct? Improvements there translate into fewer retries in practice.
Any surprises?
2. First, the approach works even with a tiny memory, often just a couple of short notes. Second, with a weaker coding model, reflections can make behavior more stable, but may not lift the average as much. That suggests strong self-correction emerges more clearly with stronger base models.
That tracks. Any caveats we should keep in mind?
A few. Reliability depends on the evaluator, especially test suites in coding. Some studies use modest samples in specific subtasks, so treat results as trends rather than definitive rankings. Reproducing everything can be costly because several runs use proprietary models, even though code and logs are shared. And there's no formal convergence guarantee. It's a pragmatic recipe.
So it's practical and promising, but still experimental in the scientific sense.
Exactly.
How does this compare to other agent patterns like React or self-consistency voting?
React interleaves reasoning and acting within one attempt. Self-consistency samples multiple chains of thought and votes. Both help within a single episode. Reflection is complementary. It carries lessons across episodes, so the second and third tries are informed by what failed before. In practice, the paper builds on top of strong baselines and adds reflections rather than replacing them.
If I'm a practitioner, what's the minimal setup to try this?
Start with a reliable evaluator. For Q&A, that's straightforward. For coding, invest in better tests. Then create a small reflection prompt that asks the model to summarize the mistake and propose a concrete adjustment. Keep a tiny memory, 1 to 3 notes, and feed them back before the next attempt. Limit each note's length so you don't crowd out task context.
I like that it's simple. Looking ahead, what would you explore next?
Richer memories that retrieve the most relevant lessons and compress older notes into general rules. Stronger evaluators, like property-based testing or mutation testing, to reduce false positives. Hybrid learning that mixes these verbal lessons with light fine-tuning. And safety. Because reflections are explicit text, you can audit them for risky strategies before tools get used.
And better benchmarks too, I imagine.
Definitely. The paper contributes a harder coding set, and expanding standardized baselines for reflection-augmented agents would help fair comparisons and transparent cost reporting.
Before we wrap, can you give a quick example of what a reflection might sound like?
Sure. In a household task, I wasted time exploring. Next time, identify the likely room and go there directly. In coding, my function fails on empty inputs. Add a check and include tests for that edge case. Short, actionable, and reusable.
That's clear. Any closing thoughts?
Reflection shows that small, human-readable notes can move the needle in a few tries. It's not a silver bullet, but it's an elegant bridge between raw trial and error and heavy training. If you're building agents today, adding a reflection loop is low effort and often high impact.
Nicely put. That's it for this episode of AI Podcast. If you'd like more deep dives on agent techniques, let us know. Thanks for listening.
Thanks, everyone. See you next time.